Hi Year 12s! In this video, we will look at simultaneous equations and solving them using matrices. Simultaneous equations represent two or more functions in a Cartesian plane, and to solve them is to find their point of intersection. There are three types of simultaneous equations that we can have. There are simultaneous equations where there is one solution, no solution, or infinite solutions. There is one solution when the equations have a single intersection point, no solutions when there are no intersections, so the lines are parallel, different lines, and infinite solutions when the two equations represent the same line. There are two main methods used to solve simultaneous equations. One is the elimination method, and the other is using matrices. Elimination is done by making the coefficients of one of the variables the same across the both equations, then minusing the two equations to eliminate the variable. For example, take 4y plus 5x equals 6 and 8y plus 2x equals 4. If we times the first equation by 2, we make the coefficients in front of y equal. Then we minus the second equation from the new first equation to get 8x equals 8, so therefore x equals 1. We can sub this into the first equation and solve for x, giving us y equals a quarter. This gets more complicated with more variables, but a few more steps of elimination will allow you to break the equation down to one variable. As long as you have as many equations as you have variables, you can find the solution. The other method is the matrix method. Matrices can be used to solve simultaneous equations, and is the easiest method if you are able to use a calculator. The basic form of simultaneous equations is ax equals b, where a is the coefficients of the variables in an n by n matrix, x is the number of variables to be solved for in an n by 1 matrix, and b is the set of numbers the equations equal in an n by 1 matrix. To solve the matrix, we need to find the A inverse. Once we find the inverse of A, we multiply both sides by this to get inverse of A times AX equals inverse of A times B. Now, the order of matrix multiplication is very important. An inverse times A simplifies down to the identity matrix, which then, when times by x, equals x, and this still equals A inverse B. Once we multiply out the inverse of A times B, we get the solutions to our variable matrix, x. Determining the inverse matrix gets very complicated for any matrices larger than a 2 by 2 matrix. However, it can be easily calculated using your calculator. Let's look at the same equations as before, but now in matrix form. So our A value equals the matrix of 4, 5, 8 and 2. So how do we find the inverse of this? First, we need the determinant. If A equals ABCD, remember, the determinant of A equals AD minus BC, which for our matrix is 4 by 2 minus 5 by 8, which is negative 32. Now, we use the determinant to find the inverse, where the inverse of A equals 1 over the determinant, D minus B minus C and A. The trick here is that we switch one of the diagonals of the matrix and then turn the other one negative. Now, if we look at our original equation, the inverse is negative 1 over 32 times 2, negative 5, negative 8, and 4 in the matrix. Now, we times the inverse of A by B to get the solution of x. Remember that to multiply matrices, we go across the first matrix and down the second. So we get y and x equals negative 1 over 32 times by 2 by 6 plus negative 5 by 4 and negative 8 by 6 plus 4 by 4, which equals 8 over 32 and 32 over 32, or a quarter for y and 1 for x. This is the same as our result earlier. This time, the method took a lot longer. However, if we had a calculator, you could use that to calculate the inverse of A and to do the matrix multiplication, so it would be much faster. It is also essential to use a calculator to solve any set of simultaneous equations with more than 3 variables, if you wish to use the matrix method. Happy studying!
Hey guys, click the link to go to the Engage Wiki, or click this link to go to the next video. Or you can just go back to Facebook, like I knew you were going to do anyway.